Hello all, welcome to the day 65 of the daily case study series for CBSE grade 12. The question goes like this. Read the following text carefully and answer the questions that follow. The given integral f of x dx can be transformed into another form by changing the independent variable x to t by substituting x equal to g of t. Consider I equal to integral f of x dx. Put x equal to g of t. We write dx by dt is equal to g dash of t dt. I is equal to integral f of x dx equal to integral f of g of t times g dash of t dt. This change of variable formula is one of the important tools available to us in the name of integration by substitution. So the entire paragraph is talking about integrating using substitution. Example, integral 2x sine x square plus 1 dx. Here x square plus 1 is taken as t. Differentiating the x square plus 1 with respect to x, we get 2x dx is equal to dt. This has to be substituted in the integral, which gives us integral sine t dt. After integrating, we get minus cos t plus c. Now in the place of t, we have to substitute x square plus 1. So we get minus cos x square plus 1 plus c. Based on this substitution method, we have to solve the questions given below. Question 1. Find integral sine tan inverse x upon 1 plus x square dx. Integral sine of tan inverse x upon 1 plus x square dx. Let's take tan inverse x as t. Differentiating this with respect to x, we get dt upon dx is equal to 1 by 1 plus x square. 1 plus x square times dt is equal to dx. Integral sine of t upon 1 plus x square times 1 plus x square dt. 1 plus x square can be cancelled, leaving integral sine t dt. Integration of sine t is minus cos t plus c. Putting back the value of t, we get minus cos of tan inverse x plus c. Question 2. Find integral tan x dx. Integral tan x dx. Let's rewrite tan x as sin x upon cos x dx. And let t be equal to cos x. Differentiating this with respect to x, we get dt upon dx is equal to minus sin x. So dx is equal to dt upon minus sin x. Replacing the dx, we get integral sin x upon cos x is t into dt upon minus sin x. Sin x and sin x gets cancelled, leaving minus integral 1 by t dt, which is minus log t plus c. Putting back the value of t, we get minus log cos x plus c. By the logarithmic properties, this can be written as log cos x to the power minus 1 plus c, that is log 1 by cos x plus c, which is log secant x plus c. Question 3. Find integral 2x upon 1 plus x square dx. Integral 2x upon 1 plus x square dx. Let's take t as 1 plus x square Differentiating this expression with respect to t, we get dt upon dx is equal to 2x. So dx is equal to dt upon 2x. Integral 2x upon 1 plus x square is t and dx is dt upon 2x. 2x and 2x gets cancelled, leaving integral 1 upon t dt. Integration of this is log t plus c. Replacing t with 1 plus x square, we get log 1 plus x square plus c. Question 4. Find integral 1 upon x plus x log x dx. Integral 1 upon x plus x log x dx. Let's take the x common. It becomes x times 1 plus log x dx. Let's take t as 1 plus log x. Differentiating this with respect to x, we get dt upon dx is equal to 1 upon x. Dx is equal to x times dt. Integral 1 upon x times 1 plus log x is t into, in the place of dx we put x dt. X and x gets cancelled. We are left with integral 1 upon t dt. Integration of this is log t plus c. Replacing t, we get log 1 plus log x plus c. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.